name is Equity Flow. It's a trading application by using Spring Boot with microservice architecture. And the actual purpose of this application is we just let the user to buy and sell the stocks and securities. Here the security refer for stocks as well. And then the reason why we opted for microservice over monolithic is because of few reasons. The first reason is it's very easy for us to handle the bug, and at the same time it's very easy for us to manage the applications as well. And at the same time, if in case if we want to scale our application to the next level in the future, it's very easy for us to scale the application if it is a microservice architecture. And then because here in this microservice architecture we just split the entire model into different type of microservices, and at the same time in future we can deploy deploy this kind of individual model in any kind of cloud service platforms like AWS or Azure or GCP, whatever it is, because it's very easy for us to handle a specific microservices instead of handling the entire project. And also if we are planning to work with a big scale project or what is that big scale project, some specific team or specific set of people can handle some particular services, other set of people can handle another services. So it's very kind of easy for us to manage the applications as well. So whatever the thing which I have listed so far in this microservice is actually a disadvantage is monolithic, because in monolithic we just keep all the modules in the same application regardless of whatever the use case it is. So that is why it's very easy, hard for us to manage the application in monolithic compared to the microservice. And at the same time microservice is not always a go-to option for any kind of product. It's kind of a trade-off. Based on our business requirement we have to choose whether we have to go for microservice or monolithic. We need to take a decision of that. It's kind of a trade-off. And when we take a close look of this particular project, I have listed four modules so far in this application. The first module is an MDM module, then the second one is a pricing module, then third one is a ordering module, and the fourth one is an API gateway. So now when we talk about the MDM module, this MDM module is a master data management. It is an important module because it is a kind of library for all the stocks. This is a place where we can keep all the informations about the stocks and securities. For example, here in this NDT, so these are all the informations we are going to store in this particular module: the QZIP ID and the symbol and the company name, and then exchange is going to be trade, and then security type, and then active flag, whether it is an active stocks or inactive stock. Here in this exchange refers for whether it is going to be traded in the Nasdaq or American Stock Exchange or New York Stock Exchange, like this. And this QZIP ID is one of the important field, because QZIP ID is a 9-character unique identifier that differentiate one stocks to another stocks. For example, even Google itself is having different types of stocks with the same Google name. We need to identify, for example, what happened in backend if we buy and sell the stocks in behind the scene. What brokers will assume that broker will never take a name of the particular stock. Instead they will take the QZIP ID to make the transactions, whether it is a buy or sell. So QZIP ID is one of the important thing. This is the one thing that differentiates between different type of stocks. And then when we talk about the second module, which is a pricing module, here this is a pricing module. So pricing module is also one of the important module in this particular application, because this is the place where we can keep all the pricings, because here in this application specifically we are providing 4 different pricing categories for the user. The first one is a market price, second one is a closed price, fourth one is a bid price, and third one is a bid price, and fourth one is a ask price. So first, market price, I think we are familiar with that. It's a market price, is a live data. It keep on changing for each milliseconds, but based upon the user willingness to buy and sell the stocks, this pricing will be keep on changing. And at the same time the use case of the market price is to buy and sell the stocks. Okay. And then when we talk about the second category which we have, it's a closing price. Closing price is the last traded price of the respective day. So we have some use cases for this also. So the use cases we have included in this particular closing prices. Some people want to analyze their own portfolio, which they have done in the last week or last year. So for this type of use cases they will go for a closed price. And at the same time, another use case, some people want to take some kind of some financial decision for their future. At the time they will use a closing price to make some analysis or research kind of thing. So this is a use case for closing price. So compared to marketplace, closing price is having a less price, because each of the pricing categories having some set of price we need to pay for the particular things. And then the third one, ask price and bid price, we are familiar with that. And then when we talk about the third module, which is the ordering module, here in this ordering model is also a very important model in this application, because this is a place where we can keep all the transactions about the stocks of buy and sell, these kind of things. See here in this particular entity, so here these are all the informations we are going to store in this particular ordering module, ID, and then QCP ID as well, and scheme and pricing and timestamp. So here in ordering module we also, yeah, in ordering module we also include what is that, we also include the type of quantity or the particular stock the particular user buy, and then the quantity of the stocks, and the QC ID, and the name of the stock, and whether it is a buy or sell. So these are all the informations we are going to store in this ordering module. So yeah, this is all about the ordering module. And then when we take a close look of this API gateway, so API gateway is one of the important model when we compare to some other models, because without this API gateway, what happened, for example, if the client or the user want to get some data about the specific model. For example, if the user wants to know about the Tesla price, at this time the user needs to run the particular ordering module. So it's not an ideal way of calling the or using the applications, right? So that is why we keep a API gateway. API gateway is a kind of an entry point for all the models, because inside the API gateway we keep and we added all the endpoints of the models which we have done so far, which we have created so far. We just receive the request from the client along with the HTTP method, whether it is get request or post request, or whether it is a update or whatever it is. So we receive the request from the client along with the HTTP method, and then we will navigate the client request to the respective endpoint to give the response to the client back. So this is the actual use of API gateway. Without the API gateway, things are very complicated. So that is why we created one API gateway to handle all the endpoints. So here you can see that for this API gateway, I use a OpenFeign. It's a Java library which is available in the Spring Boot. So it is used to write the HTTP methods to navigate the client request to the respective services, and send back the response to the client as well. So this is a use of API gateway. Here I use OpenFeign. So what happens if I don't use a OpenFeign in my application? If I don't use a OpenFeign in my application, what happens? The particular developers needs to write the boilerplates of HTTP code. So that is very complex. At the same time, it's not a readable way. That is why we go for OpenFeign. OpenFeign is just a plug. We just need to plug the OpenFeign in our application. We start to write the endpoints. This is far more easier than we compare to the traditional method, instead of writing the boilerplates code for HTTP. So that is the reason. And then this is all about the models which I've done so far, which I've created so far. And on top of it, I've also added the rate limit for this application, which I use a Bucket4G for that. Bucket4G is a Java library again, which is available in the Spring Boot. We just need to download the dependency directly from the Spring Boot, and we just plug that particular thing in our application to use it. So Bucket4G, by using Bucket4G is actually tells that how many requests a user can make to the particular server for specific duration of time. So in behind the scene, Bucket4G uses a bucket algorithm. In behind the scene, what happens? It is having one bucket. Inside the bucket, we have a token bucket algorithm. Inside the token bucket algorithm, inside the bucket, we have a tokens. So each request consume one particular token, and at the same time, the token will be added back to the same bucket after specific duration of time. For example, by default, I set a rate limit of 10 requests per second. Means if that particular count will be crossed more than 10, what happened, the particular Bucket4G, we will through the 429 status code for the user, that is a too many requests. So this is a use of Bucket4G. And then the rate limit is our wish. Based upon our requirement, we will choose a rate limit. And then what happen if you don't use a Bucket4G in my application? If I don't use a Bucket4G in my application, obviously the user can make an unlimited request. What happen if the user can make unlimited request to my server? Obviously my server will start to slow down, and at the same time there is more chances of there's a more chances my particular backend will get terminated because of that. And at the same time, there's a more chances that the malicious people or unauthorized people can get an access of my system, that is called the DD or attack, DDoS attack. And at the same time, brute force attack also, there's a more possible, if you're not if you're not include this kind of rate limit feature in our application. So these are all the things that prevent my application, if I use bucket 4G in my application. So this is the two things which I have added on top of this application. One is an OpenFig for creating HTTP method to navigate client requests to the respective modules, and the second one, bucket 4G, which is a rate limit Java library. So these are all the two things which I have added on top of it. And at the same time, since it's a microservice architecture, so that is the main reason why we go for OpenFig. So because right now we use a OpenFig to transfer data from one service to another service. Because if we take a close look of this application, this particular MDM module is strongly depends on the it strongly depends on whatever the details that we have entered. Because initially as a user we need to give this kind of informations, and then we can take a look of this pricing module. So this pricing module strongly depend on the this pricing module strongly depends on the MDM module. And then this ordering module strongly depends on the MDM module and pricing module. So here we find one pattern, that each module strongly depends or rely on some specific module to proceed its operation or make some operation. So that is why we use a HTTP method in between. So we actually streamline one particular bridge to transfer information one service to another service. So here the reason why the pricing module strongly depends on MDM module is because before storing the price of the security, the particular pricing module needs to know that whether the stock is actually available in the MDM, the library, or not. If it is confirmed that okay, the stock is available in the MDM module, then you start to store the price. Then here in ordering module, why ordering module strongly depends on both MDM and pricing? Because the order module needs to verify that whether the stock is first available in the MDM or not. Once it confirms that okay, it is available, then it move back to the pricing module to check that whether this particular stock pricing is available in the stock module pricing module or not. Once it confirm to get the data from both of this MDM and pricing module, it stores the transactions, whether it's a buy or sell, whatever it might be. So these are all the use of OpenFig. And then and also I have built a front end also for this application. For front end I opted for Angular.